Alright, in this video we're going to go over the AP Calculus B FRQ number 5 from 2006 Form B. So we're given a differential equation and we're asked to sketch a slope field at 9 different points. And when we look at our diff EQ, sometimes this can be kind of a scary one. We've got y's and we got cosine here, but if we look at the different values and we just kind of separate it, we're plugging in 3 points where x equals -1, 3 points where x equals 0, and 3 points where x equals +1. Then we're plugging in 3 points where y equals -1, 3 points where y equals 0, 3 points where y equals 1. And so if we just kind of break this down in that way and think about the two factors here, this factor only depends on x, this factor only depends on y. So if we just deal with the x's and the y's separately and then see what those factors do, I think we can work through this problem without too much difficulty. So I'm going to try to organize this a little bit here. When the x's are -1, oops, switch to my pen, not my laser tool there. When the x's are -1, we're going to get cosine of -pi. Well, cosine of -pi is just -1. When the x's are 0, we're going to get cosine of 0, which is +1. And when the x's are 1, we're going to get cosine of pi, which is just 1. If you have a hard time with those values, make sure that you're brushing up on your basic unit circle trigonometry there. Now let's do the same thing for the y's. When the y's are -1, that first term, y minus 1 squared, you're going to get -1 minus 1, which is -2 squared is going to be 4. When y is 0, you're going to get 0 minus 1 squared, which is then -1 squared, which is 1. And when y is 1, you're going to get 1 minus 1 squared, which is 0. So that last one is really nice because it doesn't matter what the x factor is. If the y factor is 0, it's just 0 times whatever is going to be 0. So all three of these ones are 0, and you have to bear with me with my stylus here. We're making a 0 slope here, a 0 slope, a 0 slope. Now this middle row, when the y is 0, that y factor is 1, as we saw. So it's just going to be whatever the x is. So if we just walk through that, the x here is giving me a slope of -1, then +1, then, oops, I missed my negative down there. Sorry about that. This was negative. Cosine of pi is -1. Another -1 here. And then at the bottom, you just have 4 as the y. So you're just going to have 4 times all of those x's. So just a steeper negative slope, a steeper positive slope, and a steeper negative slope. Again, excuse my stylus there, but when you're drawing a slope field on the AP Calc exam, it's all about relative. Your 0 slope should look roughly like a 0 slope, but for your other ones, is this exactly a slope of -1? Is this exactly a slope of 1? Hopefully yours are better than mine on your paper rather than my stylus, but what's really important is that you're showing that it's positive and that this one should be a steeper positive because it's a slope of +4 rather than a slope of +1. So the relative slopes is what you're looking at there. Okay, so let's get all of this junk out of the way. Make sure you write that down, and then we'll go on to part B. Gone. Okay. So part B, there's a horizontal line with equation y equals c that satisfies the given differential equation. Well, first of all, if the line is horizontal, that means that the slope must equal 0. So dy dx must equal 0. And then the given equation has two factors. So if we're setting this equation equal to 0, we can just set each of these individually equal to 0. So we'll have y minus 1 squared equals 0, and we'll have cosine of pi x equals 0. Now, when we solve this cosine of pi x, you're going to get x equals something. But I actually don't care, because the question specifically says a horizontal line y equals something. So this is not what we're looking for. So we just need to solve this one over here, take the square root, add the 1 over, and you get y equals 1. So that's part B. Not too bad if you, algebraically, once you kind of think about what you have to do there. If the line is horizontal, the slope must be 0. So this was the key here. And then recognizing, just set each individual one to 0, and then you don't care about this one. Part C, actually solving the differential equation. In AP Calculus, the only way you know how to solve a differential equation is by separating the variables. So you've got to make sure you do that first. So if we look at our equation and we separate, we've got to divide the y factor over to the other side. So we're going to get 1 over y minus 1 squared dy is equal to cosine of pi x dx. So this is part C here. And then we just have to take the antiderivative of each side. Antiderivative on the left is just sort of an inverse power rule here. Be careful with your negatives. So we're gonna think about this really as y minus 1 to the negative second. So add 1 to that exponent and then divide, and so you're going to get negative, oops, I want to go back to red, excuse me. We're going to get negative, divide by the negative 1, y minus 1 to the negative first. But then we also need to think about u substitution here, because it's not just y to the negative second. We've got this minus 1. But that minus 1 doesn't really matter, because it's not, the du here, if you did your u substitution, would just be 1, because there's nothing in front of the y. So adding or subtracting something doesn't change anything. If you multiplied by something or there's some other power in here, then that would be a very different problem. Okay, so that's the left-hand side. Right-hand side, we do need to do a little bit of u substitution. And if you work that out, you should get 1 over pi sine of pi x plus c. Now you could go ahead and show the u substitution or substitution rule, whatever you want to call it, but I prefer to think about this just as like, okay, if I were to do this with chain rule, taking the derivative just of this chunk here, I know that the derivative of sine would give me the cosine. And I know I would have to multiply by the derivative of the inside, so I'd have to multiply by pi. So the question is, what is this thing, cosine of pi x, the derivative of? Well, it's the derivative of sine of pi x, but with a 1 over pi in front. So when I do the chain rule, that cancels out. Okay. Now we have this initial condition, f of 1 equals 0. So let's plug that in and go ahead and solve for c, and then solve for y afterwards. So this, if we plug in 0 for y, we're going to get 1 over negative 1, and then we have negative that. So this whole thing just simplifies to be 1. And then on the right-hand side, sine of 0, if we plug in 0 for x, is 0, so we just get 1 for c here. So now we know that c is 1. Let's give ourselves a little bit more room here and solve this. So we've got I'll write this a little bit better here. Negative 1 over y minus 1 is equal to 1 over pi sine of pi x plus 1. And we just need to solve this for y. So sort of what I would think about doing here is, just think about multiplying this y minus 1 to the other side. And so we're going to have y minus 1 over on the other side, and so you're going to get then, and then divide all of this back to the left. So we're going to get negative 1 over pi sine of pi x plus 1 equals y minus 1. And there's some other ways you could simplify that, but I think that's the easiest way, is just think about, okay, cross-multiply this. Multiply the y minus 1 to the right, divide by the entire original right-hand side, and then just add the 1. So then you get 1 minus 1 over pi sine of pi x plus 1 equals y. Sorry, I kind of ran out of room a little bit, went a little squiggly, so just to be clear, that's my answer. And we could simplify that different ways. Again, you might not really like the look of this 1 over pi in the denominator, but it's a pretty ugly expression anyway, so I think we're good leaving it there. Okay.